Imagine a world where your thoughts can open doors, compose music, or type messages without touching a single key. That future is not science fiction. It's being built today through the revolutionary field of brain-computer interfaces, or BCIs. These systems create a direct communication pathway between the human brain and external devices, opening up incredible possibilities not only for people with disabilities, but for anyone looking to extend their cognitive and physical capabilities. Subscribe, hit the notification bell, and like this video to stay ahead of the AI curve. We're diving into the tech that's turning thought into action. In 2025, brain-computer interfaces are no longer confined to experimental labs. They're entering clinical trials, startups are scaling commercialization, and AI integration is supercharging their learning curves. The most advanced BCI systems are now leveraging machine learning to decode brain signals with higher accuracy than ever before. Where early BCIs struggled to translate even basic motor signals, today's models can identify patterns in speech, emotion, and intention. One of the most promising applications of BCI technology is restoring communication for individuals with severe paralysis or neurological conditions. Devices implanted on or near the motor cortex can now detect neural signals associated with intended speech or movement, allowing users to control computer cursors, spell out messages, or even speak using synthetic voices generated directly from their brain activity. It's giving people a new voice, literally. Meanwhile, non-invasive BCIs are becoming more effective, thanks to improvements in electroencephalography and signal processing. Companies are producing sleek, wearable headsets that track electrical brain activity and use it to control apps, virtual environments, or games. These devices are being used not just in medical rehab, but also in wellness, meditation, and peak performance training, helping users fine-tune their mental states on demand. But the real leap forward is happening at the intersection of BCIs and artificial intelligence. Deep learning models can now decode the brain's complex electrical chatter with unprecedented nuance. They can distinguish between imagined movements, emotional states, and visual memories. In 2025, several teams have trained AI models to reconstruct images a person is seeing, or even just remembering, based solely on their brain activity. The implications for memory, creativity, and learning are profound. In the gaming world, BCIs are pushing boundaries further than ever. Developers are testing mind-controlled gameplay, where players can move characters, trigger special powers, or influence narrative choices just by thinking. These systems are currently being refined for latency and precision, but the trajectory is clear. In the near future, your avatar will act on your thoughts without the need for a joystick or controller. Education is another area being transformed. BCIs allow real-time measurement of cognitive load and attention levels, enabling adaptive learning platforms to tailor content delivery to the brain's readiness. If a student begins to lose focus or becomes overwhelmed, the platform adjusts pace or difficulty instantly. These neuroadaptive technologies could personalize education at an unprecedented scale. In the workforce, mental workload monitoring is emerging as a key use case. Pilots, air traffic controllers, surgeons, and others in high-stakes environments are experimenting with BCI systems that detect fatigue or overload before mistakes happen. These signals can trigger alerts, handoffs, or support interventions, making critical operations safer and more reliable. But BCIs aren't just about function, they're about experience. Artists are exploring BCIs to translate emotion and brainwaves into visual or musical outputs. Musicians compose through mental improvisation. Digital artists paint with thought patterns. Entire immersive environments are being generated based on the real-time emotional state of users, creating a new frontier in expressive technology. And then there's memory. Researchers are experimenting with memory encoding and retrieval using BCI-linked stimulation. Early studies show that certain stimulation patterns, delivered while memories are being formed, can enhance recall. It opens doors to memory augmentation and potentially therapeutic interventions for conditions like Alzheimer's or PTSD. We're on the edge of a world where memory itself might be programmable. Of course, this future brings ethical and security challenges. When devices can read your thoughts or emotional states, who owns that data? How do we secure the neural interface from being hacked or manipulated? In 2025, there's growing momentum behind neurorights, a set of proposed protections around mental privacy, cognitive liberty, and freedom from algorithmic bias in brain signal interpretation. Privacy isn't the only concern. As BCIs become more commercial, questions arise about inequality of access. Will these technologies be available only to the wealthy? Will cognitive enhancement become the new digital divide? Policymakers are beginning to explore frameworks for equitable distribution, regulation, and oversight, but the pace of innovation is outstripping governance in many regions. Still, the public excitement is palpable. Major consumer electronics companies are investing heavily in brain tech startups. Venture capital funding for neurotechnology has doubled year over year, and early adopters are already integrating BCIs into daily life. From smart homes that respond to mental cues to productivity tools that adapt to your cognitive state, we are entering the era of ambient neurocomputing. There are also spiritual and philosophical questions. What happens to our sense of identity when machines can mirror or modify our mental states? Can brain-computer interfaces be used to induce transcendent states, simulate meditation, or explore altered consciousness? In 2025, research teams are exploring these questions through BCI-linked neurofeedback systems that guide users into deep states of calm, clarity, or awe. This convergence of technology and consciousness may be the most radical shift of all. As our understanding of the brain deepens and our tools to interface with it improve, we begin to unlock capabilities that once seemed the domain of science fiction or mysticism. Telepathy-like communication, brain-to-brain interfaces, or collective cognition could become possible in the coming decades. But perhaps the most inspiring breakthroughs are those improving lives today. Stroke survivors using BCIs to regain control of limbs, ALS patients composing messages without speaking, and children with mobility disorders playing video games through neural control. It's in these real stories that the power of this technology comes to life. The path forward is as thrilling as it is complex. Engineers, neuroscientists, ethicists, designers, and storytellers will all have a role to play in shaping this future. As we fuse silicon with synapse, the goal must remain clear: to amplify what is most human, not replace it. To create tools that liberate the mind, not cage it. Medical rehabilitation is perhaps the most immediate sector being transformed by BCIs. For individuals with spinal cord injuries, BCI-controlled exoskeletons are restoring movement. Patients can now stand, walk, and even climb stairs using nothing but their brain signals to issue motor commands. This kind of neuroprosthetic mobility was unthinkable a decade ago, and it is now entering clinical validation around the world. Neurofeedback through BCI is revolutionizing mental health treatment. Patients with depression, anxiety, or PTSD can now visualize their brain activity in real time and learn to regulate dysfunctional patterns. These systems empower users to rewire thought habits by reinforcing healthier neural activity, effectively turning therapy into a gamified process of self-guided brain training. Military and defense agencies are also investing in BCIs. Research is underway into enhanced situational awareness, fatigue detection, and even synthetic telepathy, where teams could communicate silently through brain-to-brain interfaces. While these applications raise serious ethical concerns, the potential tactical advantages mean development will likely continue at a rapid pace. In space exploration, BCIs are being tested to assist astronauts in controlling equipment and drones in zero-gravity environments where traditional input methods are cumbersome. A thought-commanded robotic arm or interface could enable fine motor control during extravehicular missions, or assist in medical emergencies during long-duration space flights. Cognitive enhancement is another hotbed of exploration. Startups are developing BCIs that optimize focus, creativity, or memory consolidation during sleep. Imagine putting on a headband that detects when you're most receptive to new information, and delivering micro-lessons directly tailored to your current neural state. This kind of passive learning could revolutionize education, skill acquisition, and career development. But for all this potential, the true litmus test is public trust. BCIs must prove not only that they work, but that they can be integrated into life without violating privacy, causing harm, or increasing inequality. Developers are now prioritizing consent protocols, data encryption, and opt-out mechanisms to give users more agency over their own neural data. Tech giants and startups alike are racing to define what the user interface of the mind will look like. Will it be a thought cursor, a neural dashboard, a synaptic shortcut to every device we own? Designers are experimenting with intuitive neural feedback loops that minimize training time and maximize comfort, making BCIs feel less like cyborg implants and more like natural extensions of ourselves. As sensors become smaller, implants become safer, and AI becomes smarter, BCIs will shift from assistive tools to lifestyle enhancers. You'll no longer just use your devices, you'll merge with them, and with every blink, every pulse, every intention, your world will respond not to what you do, but to who you are in that moment. We are standing at the gateway of an entirely new kind of human-computer relationship. Not one mediated by touchscreens, keyboards, or voice commands, but one powered by thought itself. The next era of innovation will belong to those who understand not just code, but consciousness. So the question isn't whether brain-computer interfaces are coming, it's whether we're ready to embrace the responsibility that comes with that power. To use it not just to advance ourselves, but to uplift one another. Because the real frontier is not the brain, it's the mind. And that, more than anything, is the future we are beginning to shape. One area gaining traction in 2025 is personalized neuronutrition, where BCIs help analyze real-time brain chemistry to determine optimal dietary inputs. Users can receive alerts when they're cognitively fatigued due to lack of glucose, or when their neurotransmitter balance suggests elevated stress. This integration of body and brain data creates feedback loops that allow for bio-optimization across the entire nervous system. Dream analysis and lucid dreaming are also entering the realm of BCI experimentation. By detecting unique neural signatures associated with REM states, some systems can deliver subtle cues, sounds, vibrations, or light pulses, to alert the dreamer without waking them. This opens doors to therapeutic dream work, rehearsal of real-world scenarios, or even problem-solving sessions within the dreamscape. Social connection is evolving too. Couples and close friends are experimenting with neural synchronization activities, where shared, meditative, or creative states are tracked and displayed in real time. This isn't just novelty. Some early studies suggest that practicing brain-to-brain coherence exercises can enhance empathy, communication, and even emotional resilience in relationships. The long-term vision for BCI technology is not just augmentation, but evolution. Think of neural firmware updates that improve memory retention, emotional regulation, or cognitive endurance. Think of distributed cognition networks, where minds connect seamlessly to solve global problems by pooling collective intelligence. It sounds radical, but every technological revolution began as a thought too wild to say out loud. BCIs remind us that the most powerful frontier isn't outer space or the digital cloud, it's the infinite space within. And now, for the first time in history, we have tools to explore that space not as mystics or philosophers alone, but as engineers of the self. The future of brain-computer interfaces isn't just high-tech, it's deeply human. If you enjoyed this video, give it a thumbs up, hit that subscribe button, and turn on notifications so you never miss what's next. Got thoughts or questions? Drop them in the comments. We'd love to hear from you. And if you know someone who's into future tech, share this video with them. This is Tech Mythos, where future tech speaks for itself.